In this video, I'm going to use an example to motivate what is known as the first derivative test for local maximum and local minimums. So we're going to try to find where this function, so parabola, has a local maximum or a local minimum. So I'm going to take the first derivative, f prime of x equals 2x plus 2. We set it to 0 equals 2x plus 2, so x equals negative 1. And I am going to draw a sine chart for the first derivative. So we have one point which is negative 1. To the left of negative 1, the derivative f prime of x is negative, and to the right it is positive. So that means this function is decreasing to the left of negative 1 and increasing to the right of negative 1, which means we have a local minimum. Right? The function is going down and then it's going back up. Again, we know this function is a parabola, so it looks something like this. I can use these sine charts, though, to decide whether I have local maximums or local minimums at some point P. And we've just seen if the sine chart looks like this, that means, so this is f prime of x, then there's a local minimum at f of c. If the sine chart looks like this, positive, negative, then the function's increasing and then decreasing. That's going to be a local max at f of c. Two other possibilities. Luckily, there are only 4. It is decreasing and then decreasing again, so no local extrema. Or finally, increasing and then increasing again, and both of these are no local extrema. So these are our 4 possibilities. Either the function is decreasing to c and then increasing again, which case we have a local minimum. It's increasing to c and then decreasing, which means you have a local maximum. And then there are 2 possibilities where we don't have a local extrema. Either it's decreasing to the left of c and decreasing to the right, or it's increasing to the left and increasing to the right. In both of those situations, we have no local extrema. And we can see, we know, again, going back to our function here, this function is a parabola. It opens upwards, so we have a local minimum. If the function had been f of x equals negative x squared plus 2x minus 3, then we would do the same thing. F prime of x equals negative 2x plus 2. We have a critical number at x equals 1. And then to the left of 1, the function is increasing. Sorry. To the left of 1, the function is increasing. To the right, it's decreasing, which means we have a local maximum. The function is going up, and then it's going down, which must mean we have a local maximum. The function must look something like that. So this first derivative test is really useful and convenient to be able to think about when a function might have a maximum or a minimum.